complex fractions. We're going to talk about how to solve equations with rational expressions on Wednesday, and we'll finish that up on Friday. So this week will be the last two sections that we have before your next test. So we'll have a review for the test on Monday, and your test is a week from Wednesday. So, just to let you know where we're headed. So this section 14.5 is on complex fractions, and then 14.6 will be on solving equations with rational expressions, and that'll be the last two sections that we'll have. So that'll be what we cover this week. Are there any questions over anything at all before we get started? As far as the quiz went, some big themes that popped up. Make sure you remember to factor out a GCF. Make sure that when you factor out the GCF, you keep it throughout the whole problem. The other big thing was that I saw that was we don't remember the difference of cubes formula. So make sure that you have that difference of squares, sum of cubes, difference of cubes formulas. Those will pop up again and again. So make sure you remember those. So those are the two big themes that I saw in the quiz. But that's why we do the quizzes, right? We want to get things straightened out before we get to the exams. So that's the whole reason why we do them. All right, well, let's go ahead and talk about this section 14.5. So in the last section, we talked about getting common denominators. We're going to have that same thought here in this section. We'll approach it a little bit differently, but the idea of getting common denominators is still going to be the same theme. So we're going to talk about simplifying what we refer to as complex fractions. All we mean by a complex fraction is that you've got a bigger fraction with some smaller fractions in the top or in the bottom or both. Okay. So in this particular example that's on your notes sheet, we've got a big fraction. There's one fraction bar that's here. You got a fraction on top and a fraction on bottom. Okay. That's what we mean by a complex fraction. Okay. Our goal is to try to get rid of the complex fraction. Okay? So notice in this case, really, in this particular one, the idea is that we've got one fraction divided by another fraction. Right? Well, we already know how to handle it, don't we? If we've got one fraction divided by another fraction, what do you do with the one that you're dividing by? Change it into multiplication and then do what with the one you're divided by? Flip it, right? So we could actually change, this one's already a single fraction over a single fraction. So we could just go ahead and convert this to a multiplication problem. We would still have the same top, and we would multiply by the reciprocal of the bottom, right? We've already done that kind of problem, haven't we? And at this point, we try to factor everything we can and simplify. Well, notice that there's not a lot of factoring we can do, right? Not much we can do with the x plus 2. Not much we can do with the 3x minus 5. But there is some canceling we can do, right? 8 and 6 have a common factor, don't they? What do they have? A 2 in common. So makes that a 4 and that a 3, right? Do you see another common factor that we could get rid of? An x, right? Notice that this x would get rid of one of those, wouldn't it? You got x squared on top and an x on bottom. So the x would cancel. So what we're left with on top is we've got a 4 times x here, and I'd still have this times x plus 2. Remember, when you multiply your fractions, you just multiply straight across, right? So we have 4x times x plus 2 on top. On bottom, this is 3 times 1, isn't it? So it's just give me a 3, and then times that second piece. So we have 3 times the 3x minus 5. So notice when it's written like this, there's not a lot of difference in what we did before. Okay? So our goal in simplifying these complex fractions is going to make it look like one single fraction over another single fraction, so we can do literally the exact same thing we just did here. Okay? So let's look at the next examples to see what we mean by doing that. All right, notice that in number 1 here, I don't have a single fraction on top and a single fraction on bottom, do I? No, so I can't start the problem the same way we just did the previous one. However, if I look at this first part and ignore this, we've talked about doing problems like that where you combine those, right? You get a least common denominator, right? Okay. Notice this has an x in the denominator, so what should we do to the first one? Add it, multiply an x by an x, right? So on top, I can multiply that first thing by x over x. What about in the denominator? What do I need to use for a common denominator in the bottom? X squared. So what should I do with that 6? Yeah, multiply it by x squared over x squared, right? Notice that I'm working on top and bottom individually, but it's just like what we did in the stuff we did in the last section, right? We're getting a common denominator. When you combine the top, what do you get? When you put the top together, what do you get? And you get a 3x plus 4 all over
9 minus 6x squared.
Oh, I still have a denominator left on top, don't I? Yeah, I got an x, don't I? Right? When I combine the top, I have 3x plus 4. It'll still all be over x, right? In the denominator, what do you have? So what do you get when you combine the denominator? 9 minus 6x squared over x squared, right? So notice that we're treating the top and the bottom like individual problems like we did in the previous section, right? Get your common denominator and divide them, or combine them. So I'm going to jump ahead to the next step. Now, does this look like the previous problem that we just did?
Yes.
Yeah, it looks a lot like it, doesn't it? I've got one whole fraction divided by another whole fraction. So how can I rewrite that? And 9 minus 6x squared on bottom? Yeah. So far, so good? Okay. So notice that we're basically combining stuff together that we've already done, right? Combining the idea of adding and subtracting rational expressions and the idea of dividing rational expressions. It's literally stuff you've already done combined into one problem. Okay? Now the last thing we're going to do is try to simplify. I think the only thing that really we can do, I mean, we can factor out a 3 there, but we can cancel this x with one of those, right?
So why don't the x squared cancel out?
With this one and this one?
Yeah.
Okay, so remember, to be able to cancel out, I have to have multiplication all the way through. This is a single term. So I can't cancel this one with this one because I would need to be able to factor out an x squared on both terms. Okay. So that's why that one doesn't cancel. Okay. Good question. So yeah, it looks like they should, right? It really looks like they should. But remember, we can only cancel multiplication. So this one says I have an x squared all by itself and it's multiplied by that whole thing. I'm okay to cancel this x squared into that x. But I can't do that one into that one at all, unfortunately. All right, so then when we multiply across, we get x times 3x plus 4 over 9 minus 6x squared. We could, there's a common factor of 3 in both of these, right? We could factor a 3 out, but there's not much more we can do past that because that would be a 2x squared, and 2 is not a perfect square. So I can't do anything with it. So it looks like I should be looking for a difference of 2 squares, right? But 2 is not a perfect square, so there's nothing we can do with that one. It's about as good as we can get. What other questions do you have on that one? Yes. Oh, here? Okay, so let me erase this and go back for the cancellation again here.
Oh, that's just that.
Yeah, so this is x squared and x. So remember, x squared really means what? It means x times x. So we're canceling one of those. I still have an extra one left over. So that's where that's getting multiplied in there. Yeah, sure.
So there's a top example.
The top one?
All of them.
This one?
Yeah.
Okay.
You was able to take out x out of the x squared. You said you can't take the x out of the x squared at the bottom. Does that make sense?
Where I did this one and this one?
Yeah.
Okay, so this one's okay because this is a single piece, right? And this is a single piece, so everything is multiplication. Same thing down here. This is a single piece. That whole thing is a single piece. So since this is multiplied, we can cancel there. It's the same idea that we had down here, since it's multiplication. There's a minus sign here in the middle, right? Right? Yeah. There's a minus sign here in the middle. So that these two things are multiplied together.
Okay.
If I want to cancel this out, it has to be as a whole chunk. Okay. Yeah. It has to be as a whole factor. Yeah, it's okay. Other questions on that one before we do the next one? Okay. Let's do the same idea with the next one. Then I'll talk about something else on the next page real quick. So, is there anything we need to do with the top, the way it sits? Do I need to do anything with this 4 all over x minus 2, or is it okay so far? That's okay, right? That's a single fraction, right? We want to get the denominator as a single fraction. So let's work on that. What do you need to multiply that? Just looking at the denominator, what do you need to multiply the first fraction by? X minus 2. And why do we multiply by x minus 2? Yeah, we need a common denominator, and the second fraction has an x minus 2 in it, doesn't it? What do we need to multiply the second fraction by? X plus 5. And again, the reason why we multiply x plus 5 in the second fraction is because the first fraction has an x plus 5 in it, right? To get a common denominator, and whatever one fraction has, the other fraction has to have. So far, so good? Ooh, hey, that shifted on me. All right, so we combine those together. In the first one, we have 7 times that whole x minus 2. In the second part, we have the 9 times the whole x plus 5, and that's all over x plus 5 times x minus 2, right? That's our common denominator. Yeah. Okay. Now we have a whole single fraction here, but I think it's probably a little bit easier if we go ahead and simplify this first before we go ahead and flip it. Just make it look a little bit nicer. We can distribute the 7 and distribute the 9 and combine like terms. Let's do that first. Didn't leave a lot of room on that page for this one. So if we distribute that 7 through, we get 7x minus 14. Distribute that 9 through, we get 9x plus 45. What do you get in the top of the bottom? I know it sounds weird, right? What do you get for the numerator of this fraction that we're working on right now? 16x plus 31 when we combine our like terms. Okay. I know it looks a little bit messy because we're working on the top and we're working on the bottom, but we're not doing anything new. Right? This is the stuff that we did in the last section. Now we've got single fraction on top, single fraction on bottom. How can we rewrite that? How can we write this now? We've got single fraction on top and single fraction on bottom.
Multiply.
Yep, 4 over x minus 2 times. Oh, so you've already gone to the next step. So you just first flipped it, right? All right, so now we've got one fraction divided by another, so we're just multiplying by the reciprocal, right? Make it multiplication and flip it over. Now do you see anything that cancels? Yeah, I got a whole, right? This is a whole factor now, so we can cancel that whole factor with that whole factor. And then multiply. That's the only thing that really goes away, so we can multiply across. So really, this stuff is just combining the previous two sections that we did, right? What questions do you have on that one? All right. Let's look at the next couple together, and then I'll go ahead and let you turn you loose on your worksheet here. Because especially the number 4 is definitely different than things that we've seen because we got negative exponents, right? So we'll talk about that for a second. All right. Let's look at this one. Again, complex fraction because we got fractions in the numerator, fractions in the denominator. Let's get common denominator. Looking just at the numerator, what do you need to multiply the first fraction by? Yeah, the y cubed. Good. What do we need to multiply the second fraction by? X squared. Good. Everybody see y? If not, now's the time to ask. Yeah, everyone see y? I also see x. But everybody see y? All right. You tell me what the denominator should look like. Before we simplify, you tell me what the denominator should look like. Well, before we simplify, if we do that, 4 over x cubed is going to be times. Good. And the next piece will be 2 over y squared times x cubed. Good. And remember, again, we got to keep everything equal. So whatever we do to the bottom, we also do to the top, right? All right. What does your numerator look like when we combine? Say it again. So if we're on the top, we add across. Exactly right. But are these like terms though? Okay. So what will we get? You're doing it right, but what will we get? So the 6 will go with the x squared, and the 5 goes with the y cubed. Yeah, there we go. Yep. We're going to do the 5 times the y cubed and the 6 times the x squared. They're not like terms, so the best that we can do is 5y cubed plus 6x squared. What's the denominator? What's the bottom of the top?
4y squared minus 2x cubed
So you're on the bottom of the, you're on the top of the bottom, but you're right. That's right. Okay. But what about the denominator there up at the top? Good. Oh, okay. So remember when we add, we just leave the same denominator, right? So it's just the x squared y cubed. Yeah. Okay. What's the denominator in the denominator? The bottom of the bottom. Good. Yeah, so we just add or subtract across the top, bottom stays the same, right? And now we have single fraction over single fraction, right? So how do we rewrite this before we try to simplify? How does that get rewritten? Before we try to do any simplifying at all, how would we rewrite it? Yep, multiply and flip. Good. So rewrite the top and flip the bottom. Oops. Flip the bottom. We just rewrote the top again. All right, rewrite the top, flip the bottom. What things do you see cancel? Yeah, the x cubed and the x squared are nice candidates, right? There's three, it's x times x times x on top and x times x on bottom. So what are you left with then? This x on top. What else do you see goes away? Good. Yeah, the simplification is exactly the same. It's just flipped upside down, right? There are 3 factors of x on top and 2 factors of x on bottom. So when I cancel, I'm left with 1 factor of x on top. Same thing, except that the y's on bottom this time. There's more y's on bottom than on top. And now again, we just multiply across. So what do you get on top? Yep, x times that whole thing, and then over y times that whole other thing. Yep. Okay. Yes. Which one?
So we're only simplifying if it becomes like the big one and 2. We're only simplifying this part. Or not.
Yeah, we're just simplifying and trying to make it a single piece. Yep.
Oh.
Yep. All right, let's do this last one. I know it looks a little bit different, but it ends up being exactly like the previous problem. So we just need to talk about what we mean by a negative exponent. And all a negative exponent means is you make a reciprocal. So all it means to do is take that x and put it in the denominator. It's just a shorthand notation for a fraction. That's what the negative sign means. Okay. It says make a fraction, so just flip it upside down, and then the exponent becomes positive. So what's the next piece going to look like? Good. 5 divided by y squared. The next piece, 4 over x squared, and the other one's going to look like y. That's cute. Yep, that's cute. Yep. Okay. Does this one now look like the previous one? Just with different numbers? Okay. Work on that one for a minute. See if you can get to a final answer. We'll go through that one, and then I will turn you loose on worksheet. Ready to talk about this one? Yeah. What did you multiply on the top? What did you multiply the first fraction by? Y squared, good. And what did you multiply the second fraction by? X cubed, good. In the denominator, what did you multiply the first fraction by? Y cubed. And the second one? X squared. Good. So far, so good? All right. After you combine the top, what does it look like? Yeah, it's okay. 2y squared times 5x cubed over. Good. And then the denominator you would get
4y cubed minus 7x squared.
Okay, over
X squared y cubed.
Good. Remember again, we've got our common denominator, so we're just adding or subtracting across the top and keeping the same denominator, right? So we have 2y squared plus 5x cubed on the top when we add across. The common denominator was x cubed y squared. In the denominator, we had 4y cubed minus 7x squared, and then the denominator is x squared y cubed. What's next? Yeah, this is now a problem like we've done before, right? Multiply and flip, the second one. So we've got 2y squared plus 5x cubed over x cubed y squared times the reciprocal of the denominator. Yep, so x squared goes into the x cubed. What's left? On top or bottom? Bottom, good. Y cubed and y squared, what's left? On top, good. And then now we can just multiply across. And no real need to distribute. And that's it. That okay? All right. Why don't you go ahead and work on the worksheet? Holler if you've got questions. That was weird. I click on. Me right there. Sorry, I'm just trying to get this thing to work. What is going on with this thing? Okay, do it this way. I would multiply by 2. You want your least common multiple. Yeah, that's exactly right. You got it. Oh, do you have a question? I'm sorry. I just didn't hear you. I'm sorry.
So about these, where you 500x without 500.
So I would look for the least common thing to get multiplied by. So we already have four. We already have an x. So I don't need to worry about an x. What do you multiply the 4 by? You need 8. 2. So you can just multiply that by 2. Yeah. And that makes life a little bit easier.
This is the 5 by 2.
Both the top and the bottom. So the 5 by the 2 and the 4x by the 2. Just doing that. I don't think Say it again. That's what's up. Oh, did I not flip it over? Sorry, I thought I did. I thought I flipped it. Sorry. Thank you. See you Wednesday.